This is Algebra 2 with Trig, Semester 1 exam review. This is the second part of Chapter 7. We're going to solve the exponential equation. Now the way we look at this one is we have exponents that need to be solved for on both sides. We need to look at the numbers that they give us and consider if we can get the same base out of them. 9 is made up of 3's. Notice how 3 is not made up of 9's. So don't try to take 3 and square it to make it look like a 9. But the 9 is made up of 3's. 3 times 3. So if 9 is 3 squared, when we raise a power to the power, we're going to distribute. So we'd have 4n plus 14. Now we have the bases the same. If the bases are the same, then we can set our exponents equal to each other. And by subtracting x, well, let's see. These should be x's, not n's. Gotta have our variables the same. Subtract x from both sides. Here we're going to subtract, let's see, doing this kind of crazy like. Now we'll add our, no, still won't. This was a positive 14 with a 3 in them. Subtract the 14. 3n equals negative 15, so n's going to be negative 5. Again, I came up with n somehow. It's actually x. So x is negative 5. That would be the letter B. We're going to solve the logarithmic equation. Now look at this logarithmic equation. We want to get the x by itself. Well, first we need to move the 6 across. Now we have a logarithm that equals a value. So, since we don't have an expression, we don't have an x variable for the exponent, we don't need the logarithm. So we're going to write this in exponential form. 4 squared equals 2x minus 1. That's 16 equals 2x minus 1. And then that's going to come out, we'll add 1. And divide by 2. It was a bit concerning at first to see that we were getting 8.5. That would be our x value. Number 15. Solve the exponential equation. Now look at this one. We only have an exponent on one side of the equal sign. We don't have it on both. So when we look at this, it's not written on both. Sometimes we would have to write a logarithm for this, which could work. You could solve this using logarithms just fine. I'll show you how to do that. But also, it's possible to get our bases the same. Sometimes we can't do that, but in this case we could. So we can get the bases the same because 64 is made of 4 to the third power. Now the bases are the same. We can set our exponents equal to each other. And when that's going to happen is when x equals 4, which is letter A. The other method you could have solved this with, we could have taken the 4, 2x minus 5 equals 64. It would have been possible to have said log base 4 of 64 equals 2x minus 5. Then here we could have come up with 3, or you could have done the change of base formula, and you could have done log base 64 over log base 4, and that's a value of 3. So that's 3, and then you can get 8, and x equals 4. So there's different ways to think about it. Since 64 was a power of 4, it worked out really clean. 16. Solve the exponential equation. So we look at this one. You can't make that 15, but we can divide the 3 to both sides. Here's an example where you can't make the bases the same on both sides. So if you can't make the bases the same on both sides, then we need to use logarithms, because we're solving for an exponent. Log base 5 of 8 over 3 equals x minus 6. That would be our logarithm. Now, 5 to what power equals 8 over 3? Well, we would need to do the change of base formula. In doing our change of base formula, use your calculator, and we could say log of 8 divided by 3, and then we could divide that by the log of 5, and that gives us 0.085. Then we would add 6 to that. Now when you do your work, don't use a rounded number. Use the actual value, the answer key, to allow you to add 6 to the whole value. So this is about 6.085. So it's not just here 6.085. I'm not getting any of those to work out. So let's go back and check our workout. I think there might be something wrong right here. We still want to divide by 3. We still want to do the change of base formula, so we know that that's right. So now I'm going to come down and try my calculator again. Let's try log 8 divided by 3. Must have typed something in there funny. And then we're going to divide. We have to divide by the log of 5. And there we get our 0.6094. And then we're going to add 6 to that to get 6.6, kind of round that up to a 1. So that's where this value would come in handy. So our answer is C. So in a multiple choice test, that really can save you, as long as you're not making other mistakes that are predetermined in your A, B, C, D options. But if you make your own mistake, you can recognize that's wrong, make a change, figure out the right way. Number 17, we're going to solve the logarithmic equation. So our first step is going to be to add 9. Some people might think about putting the 2 up as a square to what you're taking the logarithm of, but you can also divide by 2. You could call that 4.9, you could call that 9 divided, or 4.5, or you can divide 9 by 2, however you want to phrase that. Since these answers are in decimal, you might as well put that into a decimal. Now we have a logarithm that equals a number. There's no variable for your exponent. We're going to write this in logarithmic form. And we'll find out that 3 raised to the power of 4.5 is 140.29. We'll subtract 1 to get 139.29. And then we'll divide by 2. So taking our calculator, we did that, then we subtracted 1, and then we divided by 2. We should come up with 69.65. That'd be letter B. Number 18. We'll solve the logarithmic equation. Notice that with this one, you have 2 logs and they're equaling each other. I'm sorry, and they're adding each other. If they're adding each other, we're going to write it as a single logarithm. We'll condense it. So we multiply the x and the x minus 6 together. Now we have our logarithm that equals a constant. There's no variable on this side, so we don't need a logarithm anymore. So 3 to the third equals x squared minus 6x. Well, 3 to the third is 27. So I'm going to subtract that 27 over to the other side. And then when we try to factor that apart, we get x and x. 9 and 3 make 27. A negative 9 and a positive 3 multiply to be a negative 27 and add to be a negative 6. So our 2 answers are x equals 9 and x equals negative 3. And of course, that one would be extraneous. So positive 9 is your best answer. Be careful of the trick over here with A, because negative 3 was not a solution. Negative 3 was not, just the positive 9. On the last page that we have, this is solving a logarithmic equation. ln, remember that's natural log. We're going to subtract 5. We'll divide by 3. Now, because the logarithm equals a constant value, we don't need the logarithm anymore. So we look at the base. For a natural log, it's e. So e to the fourth power equals x minus 7. We can use our calculator and say that e to the fourth power gives us 54.60. And then we would add 7 to that to get 61.60. So our best answer would be C, and it would be an approximate answer, not an exact answer. Another logarithmic to solve. Here we have 2 logs. Now this is a little tricky. If we would have 2 logarithms with the same base, then we could set what they're taking the log of equal to each other. But in this case, what we're taking the log of here is x minus 3, and what we're taking the log of here is just x. The x plus 3, this 3 is not part of the logarithm. It's the extra part. It's not in parentheses. So what we would need to do here would be to bring that x minus, or that log of base 2 of x across. So I could see many people not quite setting this one up right. This is a tricky one. You got to understand the importance of the parentheses. So, forgot part of my x minus 3 log base 2. Okay? So, now we have 2 logs that are subtracting each other. The property we learned about that was division. So this would be log base 2 of x minus 3 over x. And that would equal 3. Because you have a logarithm, and it equals a value, and that value doesn't have any variables with it, we don't need the logarithm. So we're going to say 2 to the third power equals x minus 3 over x. So 8, 2 times 2 times 2 is 8. So that's kind of like saying 8 over 1 and then cross multiplying. So we're going to get 8x equals x minus 3. And then when we subtract our x across, we'll get 7x equals negative 3, and x equals negative 3/7. So let's look at our answers. We got x equals negative 3/7, so it looks like that's probably it. Alright? But it's negative. That's concerning. So when we plug that back up into the original, you can't take a logarithm of a negative number. And it would be taking it of the negative number here, or you could consider it taking the logarithm of a negative number there. So this is actually no real solution. There isn't an extraneous in this case because there's not one that works or one that doesn't. No real number. Write a power function that goes through these 2 points. So we have our 2 values. This is our x and our y, our x and the y. So we'd say 4 equals a, 1 to the b power, and we also have 8 equals a, 4 to the b power. We're going to take this equation and solve it for the a value. Then we'll plug it in over here. We're going to reorganize that so it's 8 equals 4 times 4 to the b over 1 to the b. Now we can pull that b out, and 4 to the first 4 divided by 1 is just 4. Now we can't multiply those 4's together because that makes 16. It's not 16 to the b power, it's only 4 to the b power. Now we'll divide by 4. Now we're solving for the exponent, so 4 to what power equals 2? So it's a logarithm, base 4 of 2, that equals b. And if you're not sure what it is, you could use a change of base formula, but it would be the square root of 4 makes 2. So b would have to equal a half. Change of base formula, if you didn't know that, you could say log of 2 divided by log of 4 and get 0.5. So obviously that narrows it down to this guy right here so far. But now let's take our b and plug it back into our a value. So a equals 4, 1 to the half power. Well, the square root of 1 is 1. It didn't matter what b was for a. A had to be 4. So we could have narrowed it down to a and b right away. The choices of a and b. And then figuring out what b was solidified that answer. Okay. Now we're going to do an exponential function. Very similarly done. Maybe not quite as mathy. A little bit more just algebra rather than the logarithms, which is truly an Algebra 2 topic. Oh, then we've got to answer the question. They want to know what f of 5 is going to be. So we'll get to use our equation to answer the question. Good question. So we're going to start out with 8 equals ab to the 0. And we'll start out with 2 equals ab to the second. So here we can say 8 divided by b to the 0 equals a. Well, anything to the 0 is 1. So a is just going to be 8 divided by 1, which is just 8. So we've got that part taken care of. And we'll bring that up here. So 2 equals 8b squared. Divide by the 8. So now we're going to have 1/4 equals b squared. We can take the square root of both sides. And when you take the square root of both sides, theoretically you'd have plus or minus 1/2. By looking at our points to help us narrow down what we're going to be using, we're up at 0, 8, and 2, 2. We see that this is an exponential decay model. So we know that b had to be less than 1. We know it's not reflected so we know that the b is going to be positive. So the b that we're going to be looking at is 1/2. So now we're going to take our value and say y equals the a value, which was 8, to the 1/2 x power. That's our equation. And when we do f of 5, that becomes a half times a half times a half times a half times a half, which is 1 over 32, or you could do the decimal version of that, times 8, which is 1/4, which is 0.25, but that's 1/4, and it's positive, and that matches. There is no negative answer, so the negative half would have given you a negative 1/4, so we're all set. That concludes Semester 1 exam review. Good luck.